All right. So let's go over some questions from. All right. Let's go over some questions from our quiz 4, which is from Unit 6, Module 1, Acid-Base Chemistry. Okay. This quiz focuses on identifying acids and bases, and then identifying conjugate pairs, and then doing simple calculations of pH, and then Ka and Kb values using Kw. Okay, now let's start with question number 1. The following substances are pharmaceutical drugs. The pK values are provided, and then you are asked to find how many of these drugs are expected to generate a pH less than 7. Okay, we know if something generates a pH in water less than 7, that has to be an acid. Okay, and then when it comes to acid, the acidic groups are carboxylic acids. Okay, those are weak acids, and then we talked about how HCl, HNO3, H2SO4 can be strong acids, but in this case, we only have carboxylic acids groups here. You can see in both um, dolobit and depakine has this carboxylic acid group, making them acidic. When it comes to the first molecule, Cymbalta, it does not have a carboxylic acid group. It has only this uh, amine group over here, which makes the base. Okay, so both dolobit and depakine will produce a solution, aqueous solution, which has a pH less than 7. So therefore, the correct answer for this question is 2 of them. Okay, let's my doodling and move down a little bit. And then the second question, I mean, is another version of the same question, the pH of 7. Oh, I mean, not pH of 7, greater than pH 7. Which of the above compounds will produce a pH greater than 7? So if the pH is greater than 7, it's going to be a base. And then only base we have here is the first molecule over here, because of this amine group. Amines are accepting protons from water, generating OH minus ions, and that's why the pH is going to increase greater than 7 when you have a base group like a basic molecule like Cymbalta in water. But it's only one of them is the correct answer here. Okay, now with that, second question. Let me get rid of my doodling first. Which of these substances will be formed when Cymbalta reacts with water? Cymbalta is a base. Okay. Again, what bases do is they accept a proton from water. Okay, let me draw a water molecule over here. Okay, because the lone pair on this nitrogen can be used to abstract or accept a proton from water, which generates OH minus ions. Okay, going to produce OH minus ions plus whatever this molecule is, and then it's going to have an extra proton now, and it has one hydrogen here right now. After accepting another hydrogen, one of the proton is going to have 2 hydrogens. It's going to have plus charge as well. Okay, I haven't drawn the rest of the molecule. In this case, I'm going to call the rest of the molecule, which is this part of the molecule, and now. Okay, that's what I did there. And then if that happens, the only difference between this molecule, the neutral molecule, and then the molecule after accepting the proton is it's going to have 1 more proton than before. Okay, so it has only 19 protons before accepting the proton. After reacting with water, it's going to have 20 protons. Not only that, it's going to have a positive charge because it just accepted the proton with a positive charge. Okay, so the correct answer is not 18. Okay, they are out, but after accepting the proton, the charge has to be positive, not negative. That is out as well. Correct answer is last option over here. Okay, moving down. Question 2. Okay, we're moving to dolomite. When dolomite reacts with water, it's an acid. It's going to donate a proton to water. Okay, so this proton over here will be donated to water because oxygen of water can accept that proton. So we have two lone pairs on water, on oxygen of water. Okay, it can be used to accept this proton. I'm just going to break this OH bond to its oxygen. Okay, as a result of that, we're going to get, let's say this is R, or the rescue molecule, we call this R. Okay, we have R, and then from the carboxylic acid group, we are left with two oxygens, and one of them will have a negative charge. So it's going to be this molecule over here. And plus is 3O plus. Okay, that's how it generates its 3O plus. And then as a result of that, its 3O plus is increased, and its 3O plus concentration is increased. Therefore, the pH decreases. Anyway, so now when it is neutral, it had this formula. When it reacts with water, it's going to lose one proton. Therefore, this 8 protons in this is going to become 7. Okay, and not only that, it's going to get a negative charge. Okay, so only formula here with 7 protons and a negative charge is the first option. That's why this is the correct answer. It is not 9. It's going to lose a proton. Right? It's not going to get a positive charge because it loses the positively charged proton. It's going to get a negative charge. Therefore, the third option is out as well. Okay. With that, okay. So reacting. So when the depletion reacts, it's going to be the same scenario. It's going to lose one proton and it's going to have a negative charge. Therefore, number of protons in depletion will be 15. And then on top of that, it's going to have a negative charge. Therefore, it's going to be option 3 over here. And moving on, question 3. The pK values are given the same. The pH of the solution of one of these drugs is close to 4.3. What is the concentration of hydroxide ions in this solution? Okay. And we know that pH is equal to minus log H3O plus concentration. Let's say H plus concentration. Okay. And then, but what they're asking is not the H plus concentration, the OH minus concentration. All right. There are two ways of doing this. Okay. You can first, and then you can first find the H plus concentration and then use that to find OH minus concentration, or you can find POH and then convert that to H plus, can convert that to OH minus concentration. So from this equation we know, so let me remind everybody. So if you have P of X, okay, P of X is always minus log X, okay? So, and also if you want to find X, when you know the PX value, the X should be equal to 10 to the power, minus sign now, of minus P of X. Okay. Now, if you want to find the H plus concentration when you are given the pH, which is 4.3, and that should be H3O plus concentration. Okay, H3O plus concentration must be equal to 10 to the power of minus pH, or minus 4.3 in this case. would be the H3O plus concentration. Okay, and we know H3O plus concentration, okay, times OH minus concentration is equal to KW. KW, okay, KW, which is equal to 10 to the power of minus 14, minus 14 at 25 degrees Celsius. We have to assume that the temperature is 25 degrees Celsius if they are given, if that is not given to you. Now, therefore, the OH minus concentration should be equal to 10 to the power of minus 14 divided by H3O plus concentration, which is 10 to the power of minus 4.3, right? And this is equal to 10 to the power of minus 9.7, okay? And then that is gonna be equal to, if you use the calculator, that will be equal to 2 times 10 to the power of minus 10. So this will be your answer. Okay. Now, there's another way of achieving the same answer. If you can remember this equation, pH plus EOH, okay, that is equal to pKW, which is 14. Okay, now pH is 4.3. Okay, so 4.3 EOH is equal to 14. Okay, now for POH is equal to 14 minus 4.3. 14 minus 4.3, which is 9.7. Right. Now again, we go back to this equation. Px is equal to minus log x, then x is 10 to the power of minus px. Okay. Now, if you want to find the OH minus concentration now, OH minus concentration is equal to 10 to the power of minus POH, or 10 to the power of minus 9.7. Right. That's your answer for the OH minus concentration is going to, which will turn out to be 2 times 10 to the power of minus 10. Okay, so that's how we calculate the OH minus concentration or H2O plus concentration when you're given the pH or POH. Now, with that, let's move on to another one. Okay, and the same thing here, same procedure. Okay, so given the pH, right, then you ask to find the OH minus concentration. Okay, so again, the OH minus concentration, or we can find the POH first. Really quickly now, POH is 14 minus pH. Okay, so 14 minus pH, which is 9.7. So this is gonna be equal to 4.3. Now for OH minus concentration must be equal to 10 to the power of minus 4.3 molar. Okay, it's going to be 10 to the power of minus 5 something, so it's going to be the fourth option here. Okay, now moving on to the fourth question. They're asking which is stronger, uh, Dolomite or its conjugate species. Okay, now the strength of anything is all about the extent or the K value. Okay, now you are given the pKa values here. Let me see if I can write. Okay, so for Dolomite, the pK is 2.7. Okay, and we know that pKa uh, pKa plus pKb is equal to pKw or 14 at 25 degrees Celsius. Okay, and therefore pKb must be equal to of the conjugate. So now this is for the weak acid, pK is for the weak acid, and the pKb is for its conjugate base. Okay, that must be equal to 14 minus pKa, which is 14 minus 2.7. Okay, it's gonna come out to be I'm gonna say 11.3. Okay, and therefore Kb must be equal to Kb. Probably try that one more time. Okay, therefore Kb must be equal to 10 to the power of minus pKb, which is minus 11.3. Okay, and the Ka pK is 2.7. Therefore, Ka is equal to 10 to the power of minus 2.7. Okay. Now, obviously, we have a larger Ka value compared to the Kb value. So let me write that. So, okay. So we see that Ka is greater than Kb. Okay. This means the acid form, which has a larger Ka value, is going to be more, it's going to be stronger than the base form because it has a larger Ka value. Right? So the acid form is Dolomite itself. Now for Dolomite, well, the acid form is stronger than its conjugate base because conjugate base has a smaller Kb value. Okay? And let's move on to the next question. Right? Now they're asking about the pKa. Okay, the same thing again. Right? So you're given the pKa value, and with this we know the Ka. I'm having trouble with writing K actually, and the A is fine. Ka must be equal to 10 to the power of minus 4.8 because 4.8. Okay, because the same argument px is equal to minus log x. Okay, in case you forgot that. Okay, px is equal to minus log x. It can be pKa, pH, pOH, pKw, whatever. Right, and then if you want to find the x, if you're given a px, then that should be equal to 10 to the power of minus px, and that's how I know it. Just remind everybody about that. Anyway, so Ka is this. Okay. Now, since we're given the pKa, we can find the pKb. Okay. So the pKb should be pKw minus pKa, which is 14. pKw is 14 minus pKa is 4.8. Okay. So this comes out to be 9.2. 9.2. Therefore, Kb is equal to 10 to the power of minus 9.2. Right. Now again, Ka here is a larger value compared to Kb, okay, because 10 to the power of minus 4.8 is greater than 10 to the power of minus 9.2. As a result of that, the acid form, which is the depakine, is going to be stronger than the base form. Okay, that's about that. Moving on, question 5. If the concentration of hydronium ion is this, estimate the pH. All right, so this again, really straightforward plug and chart calculation. So again, pH is equal to minus log H3O plus concentration. Okay, and therefore this should be equal to minus log 3.77 times 10 to the power of minus 4, right? And this is going to come out to be 3 point something, only 3 point something. That is option 1. So that should be the correct answer. Should be 3.4. Again, this is plug and chart, straightforward calculation. Okay, now I'm going to skip the second version of that. This is the same thing. Okay. Right. And then, yeah, I mean, if we do the same calculation, you can get 3.7. Okay, now with that, let's move on to the last question, I think. What is the value for the equilibrium constant K for this reaction? Okay, now I've given some hints here, but I mean, you will not always get these hints, but let's try to follow them along. Okay, so we're talking about C8H15O2 minus. Okay, so that seems to be, there are no nitrogens or something like that. Therefore, it seems to be talking about depakine. That's the first thing you need to appreciate. Okay. Now, depakine has a molecular formula of C8H16O2, and now this structure given to this substance given to you here has one less proton, one less hydrogen than depakine, and a minus charge. Okay. Now, what do you think this is? Okay, this is the conjugate base of depakine. All right, this is what you get when depakine reacts with water, because you're going to get the conjugate base. Okay, now the question is, when the conjugate base reacts with H2O, okay, you're going to get this equilibrium. Okay, and then this equilibrium constant is also called Kb, because this is the base dissociation constant. Now the question is, what is the value for that? Okay, again, the answer is very straightforward here. So if you're given the pKa, all right, you can find the pKb, because you know that pKa plus pKb is equal to the pKw, which is 14 at 25 degrees Celsius. Okay, therefore pKb is equal to 14 minus pKa. pKa is 4.8. Okay, so you're gonna get 9.2 as your pKb. They're asking for the K value, Kb value. So the Kb value must be 10 to the power of minus pKb, power of minus pkb, which is 9.2, okay, which is going to be to the power of minus 10 something, okay. It has to be option 3, okay. So be 6.3 times 10 to the power of minus 10, right? So the main thing here is to identify what is reacting with water here. What is reacting with water here is the conjugate base of diplocaine, okay? And then once you know that, once you identify that, if you are given the pKa for the acid, you can find the pKb for the conjugate base directly, okay? Because you just subtract the pKa from 14, the pKw, which gives you the pKb, and then that will give you the equilibrium constant, or the base dissociation constant, as we have calculated here. Okay, it seems like many of us had trouble with that calculation, but we just need to practice there a little bit. Let's try it one more time. Again, you're given something with F2O3, okay? The one with F2, F5 chlorine is dolomite. And then if you notice carefully, dolomite has 8 hydrogens, but this guy has only 7 hydrogens, and also minus charge, right? And this is what we get when dolomite reacts with water, or this is the conjugate base of dolomite. The question is when the conjugate base reacts with water, okay, it's going to establish this equilibrium. What will be the equilibrium constant value for this reaction? Or this is the base dissociation constant. You can see that we are producing OH minus, okay, which is going to be a characteristic of base dissociation constant. Okay, again, you are given the pKa. Okay, with this you can find the pKb. We use a different color. Okay, so the pKb must be 14 minus the pKa value, which is 2.7. Okay, and it's going to be 11.3. Yeah, so pKb is 11.3. Okay, therefore Kb must be 10 to the power of minus pKb, which is minus 11 to the power of minus 11.3, and it's going to be a 10 to the power of minus 12 value. That seems to be 5 times to the power of minus 12. Okay, so it's the third option over here. All right, that's what we have. That's what we had in quiz 4. I hope that this video key helped you clarify any confusions you had. If you had any questions, we can talk during class or during my office hours. So shoot me an email. See you soon in class. Bye, everybody.